Today we're going to look at simplifying rational expressions, and the key thing to remember the rational expressions are they are just fractions, so we follow fraction rules, but the only thing that's different with the fractions is they have x's, x squareds, and so on. So we have polynomials as part of the fraction. So let's do just a couple of easy questions with just regular fractions first, and then that'll lead us into how we solve rational expressions. So the first part, if I gave you a fraction like 24 over 36, remember when we do a fraction we can divide top and bottom by the same thing. So we can divide, in this case, let's divide by 2. So that would be 12 over 18. And if we want, we could divide by 2 again, or let's divide by 6 this time. So you can divide by anything, right? You can always divide any fraction by any number as long as you do the same thing top and bottom. You're not changing the fraction. So right off the original question, we could have divided by 12 to get 2/3 all in one step. Or you also, when we're dealing with fractions, you could also times things. So let's suppose I wanted to times top and bottom by 3. So that would give us 6 over 9. So that's the same fraction. So all of these fractions are all equivalent. They're just different versions of them. And we could also times things by variables. So I could times this by an x, top and bottom. So if we had 6x over 9x, that would be the same fraction. Or we could even times it by polynomials that are in brackets. So x plus 2. That would still be the same fraction. So you can always times or divide top and bottom by anything. It can be a regular number, an x, something in brackets that's a factor. Doesn't matter what it is. What we're going to look at doing though is we're going to take any kind of question and we're going to simplify it down to its lowest terms. So in this case, out of all of these fractions that are on here, 2/3 is the one that would be lowest terms. So when we're dealing with rational expressions now, basically the idea is how do we simplify them? So we want to factor top and bottom as much as possible first. And when you factor, you're going to either use greatest common factoring, or you could do square root factoring, either one. And then once you do that, so once you're done factoring, then what you'll do is you'll cancel any of the common factors that are on the top and the bottom. So if you have anything on the top and bottom that's the same, you'll cancel those out. And then the last step is to state non-permissible values. So for every question that we do, you always have to do non-permissible values. So let's do a few different examples. We'll start with a couple easy ones. So if I gave you a simple fraction like 3a squared divided by 9a to the 3, you can see we got basically just a basic fraction. So we want to treat the 3 and the 9 the same. So you got 3 and 9, we can divide both of them by a 3. So that would give us 1/3. And now we have a squared and a cubed. So what you want to do is you want to think of those as sort of being a times a. And then on the bottom you'd have three of them, a times a times a. But we can actually cancel out 2 of them. We can take out an a squared out of each. So we have 2 a's on the top and get rid of those, 2 a's on the bottom, get rid of those. That would leave us with 1 a left over. So our final answer is 1 divided by 3a. And then your non-permissible values would be, in this case, always go back to your original. So we have an a that's by itself, so our non-permissible would be a can't equal 0. And that would be our final answer for that one. So let's do a different one. So let's suppose I give you 5x plus 3 and x minus 1. And then on the bottom we have 10x plus 2 and x plus 3. Okay, so this one's already factored out for you, so you don't have to do any factoring. So all we're doing is we're looking at, can we do any canceling? So you can see we've got an x plus 3. So we have a common x plus 3 top and bottom, that'll cancel. And then we can also divide by a 5. So that would leave us with a 2 on the bottom. So our final answer in this case then should be just x minus 1 on top. And then we have a 2 times x plus 2 on the bottom. Okay, so you just want to factor In this case it was factored, and then you cancel, and then you're done. So the last step, don't forget to do your non-permissibles. So in this case, go back to your original question. So we have a x plus 2 in brackets, so that means we'd have negative 2 as our non-permissible. We have an x plus 3, so that would mean negative 3, and the 2 or the 10 in front doesn't do anything, so we're done. So that would be the correct final answer for this one. Okay, let's try a different one. So in this case, let's suppose we have 4x plus 12 over 2x. Okay, so in this case, we want to stop. First step again, can you factor? So we want to ask yourself, can you factor it? Always try common factoring first. So is there anything that's common? And on the top we can see we got a 4, and that's it. So we can take out a 4, so that gives us x plus 3 left over. And 2x on the bottom doesn't change. So now the only thing that we got left is, out of the 4 and the 2, we could divide a 2 out, top and bottom, so that would leave us with a 2 on the top. So our final answer should be 2 times x plus 3 divided by x. And our non-permissible would be, go back to the bottom, so we have x along the bottom, so x can't equal 0. Okay, let's try one more. So let's suppose I give you x squared minus 9, and then on the bottom I give you 3x plus 9. Okay, so we want to factor this one. So looking at the top, we don't have common factors, but what we can do is take out a square root factor, so we can square root both of them. So that would give us x plus 3 and x minus 3 once we square root each of them. And then on the bottom, we can take out a common factor of just a 3, so divide everything by 3, so that'd give you x plus 3 left over. So then our final answer is, you can see we have an x plus 3 that's common, cancel those out. So we're done. Our final answer is x minus 3 on the top and 3 on the bottom. And our non-permissibles, when you're doing non-permissibles, if you have any kind of factoring on the bottom, go to the factored version because it's already the simplest for you. So you can see here the 3 will do nothing, and then we have x plus 3, so that means our non-permissible will be negative 3, the opposite. And that's our answer for that one. Okay, so that's it for simplifying rationals. So it's the same process over and over. Just a quick review. Make sure whatever question you get, before you do anything, you always want to factor the top and the bottom first. Always look for greatest common factoring first, and then try square rooting if that doesn't work. Once everything's factored, you can cancel things on the top and the bottom that are the same. And then the last step is always state your non-permissible. And a good tip for that is take them from the factored step. So when you're doing your non-permissibles, go to where it's factored in order to figure those out. Okay, so it's usually your second step after you factor it. That's the part where you want to get your non-permissible values. And that's it.